This is Idamati from EEB. Here I am going to deliver a presentation about a capacitor and its working principle. What is a capacitor? Capacitor is an essential component of a circuit design. And in fact, after the resistor, it is the second most useful passive component in the circuits. Now, these capacitors are available in various shapes and sizes, but the basic function of any capacitor is to store electrical energy. The capacitor consists of two metallic plates separated by dielectric material. Now, this dielectric material is the insulating material and opposes the flow of current. So now let's understand. This is a two metal parallel plates. It will be separated by dielectric material. Hence, in between the plates, charges did not pass. Now, let's understand. When we apply the voltage to the capacitor, then how the energy is stored across the capacitor. Now, before the application of voltage, the two conducting plates of the capacitor are electrically neutral. It means that it has equal amount of positive as well as negative charge. But once the voltage source is applied to the capacitor, once the voltage source is applied to the capacitor, then from the top plate, the electrons or the negative charges attracted towards the positive terminal of the battery. The electrons are pushed towards the and through the negative terminal of the battery, the electrons are pushed towards the bottom plates of the capacitor. Now, because of the dielectric material between the two plates, electrons which are collected at the bottom plate of this capacitor are not able to cross this barrier. And because of that, you will observe that over the period of time, the electrons will get accumulated at the bottom plate of this capacitor. So, over the period of time, the top plate will have a shortage of electrons, while the bottom plates will have excess of electrons. Or we can say that top plate will get positively charged and and the bottom plate will get negatively charged, and because of the charged particles, the potential difference will get developed across the two plates. Now the building of charges across the two plates will continue till the point the potential difference that is developed across the two plates is equal to the supplied voltage. Now because of this potential difference, the electric field will get developed across the two plates. Electric field will get developed across the two plates. And this developed electric field is directly proportional to the potential difference and inversely proportional to the distance between the two plates. So, smaller the distance between the two plates, larger will be the potential difference. Initially, capacitor is uncharged, but when we connect the capacitor to the voltage source, two parallel metal plates get charged. One plate gets positive charge and another plate gets negative charge. If we disconnect the voltage, still the metal plate stores charges. A battery is connected across the capacitor to transport charge from one plate to the other until the capacitor voltage built up is equal to the battery voltage. The voltage across the capacitor depends on how much charge was deposited on the plate and also how much the capacitance of the capacitor. Capacitor blocks DC current and allows AC current. Suppose a capacitor. Capacitor is two parallel plates. A capacitor is, suppose a capacitor is connected across a battery through a switch. When the switch is on, a current will start flowing through this capacitor. After a certain time, capacitor never allows current to flow through it. Further, it is because of the maximum charges. accumulated on both plates, and capacitor acts as a source which has a positive end connected to the positive end of the battery and negative end connected to the negative end of the battery with same potency. Due to the zero potential difference between the battery and capacitor, no current will flow through it. So it can be said that initial capacitor is short circuited and finally open circuited when it gets connected across a battery or a DC source. Suppose a capacitor is connected across AC source, consider at a certain moment of positive of alternating voltage, plate 1 gets positive polarity and plate 2 gets negative polarity. Just at that moment, plate 1 accumulates a positive charge and plate 2 accumulates negative charge, but at the negative half of the supplied voltage, plate 1 gets a negative charge and plate 2 gets a positive charge. There is no flow of electrons between these two plates due to the dielectric plates between the plates, but they can change the polarity with change in source polarity. The capacitor plates get charged and discharged alternatively by AC. Capacitor resistor changes in voltage. At initial stage, when we connect a capacitor to the DC supply, there will be a small current flow will occur until the plates become saturated. Capacitor allows alternating current to pass, but it blocks direct current. When attached in DC circuit, capacitor acts as an open circuit, but due to alternating nature of AC, capacitor cannot block current in the circuit. Now let us consider a circuit which has a voltage, capacitor and a bulb, and it consists of two switches and a key. When we connect a key A to the capacitor, from the applied voltage, capacitor gets charged. When key B is connected to the capacitor, charged capacitor, the charges in the capacitor leaves from the capacitor to the bulb and this bulb starts glows. And bulb starts glows. The energy stored in a capacitor is nothing but the electric potential energy and is related to the voltage and charge on the capacitor. If the capacitance of the capacitor is C, then it is initially uncharged and it acquires a potential difference when connected to a battery. If Q is a charge on the plate at that time, then Q equal to CV. The work done is equal to the product of the potential and charge, and W equal to QV. And this is the Q. Summary. What we learned from this capacitor. Capacitor is a passive component. It consists of two parallel plates separated by dielectric. Dielectric is an insulator. One plate gets positive charge and other plate gets negative charge.